Hello everybody. In this video we're going to present an overview to On's book chapter 1 called Describing Data. My name is Fred Rispoli. So we'll briefly talk about these 6 items, some of the application areas, tables and graphs, measures of central tendency, measures of variation, percentiles, quartiles, and box plots, and some statistical functions of R. And this is really just an outline. I would say that it's extremely important that you go through the book itself, chapter 1, and there are also some class notes that might help you out, and these are all posted on Blackboard. So some application areas. Well, statistics is useful in so many different areas. It's used quite a bit in technology. These companies use statistics to study quality control. Motorola was one of the first, but also companies like Apple and Google use statistics quite a bit. Drug companies use statistics to determine the effect of drugs. The FDA requires drug companies to do long studies for 10 years when they present a new drug to the market. Even in construction, wind calculations based on the number of stories, people use statistics to study some of the possibilities of what may happen. Statistics is now being used extensively in sports to study players' abilities, player matchups, and some key decisions. The Census Bureau is really a statistical survey or data collection where every 10 years the United States tries to update their statistics on demographics. So a big project where a lot of statistics are collected. Educational companies use statistics. For example, the College Board uses statistics for the AP and the SAT exams. Insurance companies use statistics to help calculate premiums and make risk assessments. And there's, of course, many other areas. So it's one of the most practical things you might learn in a college course. Here's an example of something called control charts that's used. Product engineers are often interested in studying what's happening when items are being produced in large quantities. So what they may do is take a sample of items, maybe 5 or 10 items every 15 minutes or so, and then calculate the mean for the sample. You can see over here, here's a time, here's a mean for the sample, 27. This mean gets plotted right here. They may also calculate the range. You can see the range, 10.7, gets plotted down here. Then 15 minutes later, they take another sample of size 10, calculate the mean, and plot it. You can see here 28.8, and over here there's a range of 21.7. So this chart here is called a control chart, and it's all statistical based. You can see that this line down here in the middle is the process average. The quality control managers would identify something up here called an upper control limit and a lower control limit. And if a sample mean goes outside of these, that raises a flag and the production process may be stopped. And then this just tells one that, well, certain things are not right. Maybe it's a machine adjustment. Maybe there's a technician that's not doing something correctly. So this would stop the process, and then they would try to fix the problem. So this is all based on statistics. We're finding a lot of sample means here. These control limits might be the mean plus 3 standard deviations. and the mean -3 standard deviations. So a lot of the basic statistics that we're going to learn go into this. It's not too complicated, but this is a tool that's been used quite a bit with a lot of good success. Okay, so one of the first things that is addressed in Chapter 1 is the set of tables and graphs. So one of the first tables you might see is a frequency distribution used to summarize a data set with a table. And I'll mention 3 different types of frequency distributions. There's a grouped distribution where data is divided into groups called classes. There are categorical distributions where the classes are given by categories, might be blood types or vehicle types. And then there's even ungrouped distributions where a class consists of just one value. So these frequency distributions is the beginning of a summary process. And so here's an example. Let's say we have blood types from a sample of people are given up here. So here we just have the 4 basic blood types without the positives and the negatives. So if we were to summarize this, we would sort of count these up. There are 5 people with blood type A, 6 type B, and so on. So we have frequencies, cumulative frequencies, and possibly the relative frequency is just the frequency divided by the total. So this is an example of a frequency distribution. They're important, and these are often linked to certain types of graphs. So for a categorical distribution, your graph may be just a simple bar chart. So you can see here the bar. The frequency is given by the height of the bar. Okay. For other types of frequency distributions, in particular the ones I called grouped distributions, we get a histogram, which we can think of as a visualization of a frequency distribution where the horizontal scale is a number line, right? So we no longer have categories down here. We have a number line. And this tells us, once again, the heights represent the frequencies. And this tells us how our data is spread out. And it's a somewhat easy graph, but it's extremely important because the shape that you get here tells us a lot about our data set and helps us to determine what to do next. Here's an example of a histogram that was produced using the program R. We're going to talk a little bit more about R, but you could see that it's the command that we need here is simply hist for histogram, and this would be the variable that we are looking to create a histogram from. Now, as I said, these histograms can be really important. You want to get good at understanding the shape and what the shapes might tell you. So you could see here a normal distribution would look like this bell curve shape. The rectangular over here, well, this would be what you get from a uniform distribution. J-shaped, this is sort of an example of an exponential distribution. And then you could have some variations. You could have a bimodal situation. So these might represent the output from 2 different machines. Or maybe if you have heights of men and women mixed together, you might have something that's bimodal. And then you have these different types of skews. Another type of graph is the dot diagram. Okay, so using a number line, values are plotted as dots. So let's say we have a data set, and then our data set might look like this. So that's another way to display some data, one item at a time. It's useful when your data set is fairly small, say, 20 items or less. Another type of graph, you've probably seen these before, pie charts. Here's an example of a pie chart for enrollment data. This sort of shows you how many students are enrolled in each area. So these are fairly easy to produce, and we can easily make these in R. An interesting and useful chart you may not have seen is something called a Pareto diagram, or a Pareto chart. With the Pareto chart, people often use these to study defects in a lot of products. And so you would take a look at your number of defects, and then you would sort of order everything so that the cause with the most defects is first, and then the cause with the second most defects is second. And so these would all go down in order. This bar looks like it's larger, but this is just others. So this could be a whole combination of 5 or 6 other defects. But generally, you see the heights of these bars go in decreasing order. And then you have another graph that we use this secondary vertical axis to understand. So this tells you sort of the percent of all defects that you have so far. So this unstable cause accounts for 45.8% of the total number of defects. Up here, we now have the number of defects combined, so I would have the 45.8 plus 27.1, that gives us 72.9, and so on. And so as we get to the end, we'll reach 100%. So this is a Pareto chart, and the idea is people generally look at this 80% mark over here, okay? And they might scan this way and then come down and focus on the causes that lead to 80% of the defects. So there's a famous 80-20 rule, which says that 20% of the causes lead to 80% of the defects. So that's an important graph that gets covered in chapter 1. Okay, next we'll study measures of central tendency. So given a data set, let's say the mode is the number that occurs most often. The mean is the average I have given below. This is sort of taken from my class notes. So I took the definitions out. You'll have to take a look at the class notes to find that. The median, right, when you set up all your numbers from smallest to largest, the median is the number that's in the middle if you have an odd number of values, or if you have an even number of values, it's the average of the two in the middle. Okay, so mean, median, and mode, those are the most common. There are sometimes other types of means. For example, group means you should understand. Sometimes you have weighted means. These are all covered in chapter 1. Okay, so when I say grouped data, what we're talking about is an example like this. Let's say we have data grouped like this, and you can see, let's say these are incomes for a certain group of people. So these are scaled in thousands, so 30,000. Let's say there were 180 players that had an income of 30,000. Now this data comes from a minor league baseball team. So you could see 180 players have 30,000, 100 players have 50,000, and so on. Okay. So your data set here is grouped like this. We could think of these as specific values, that's fine. But let's say we wanted to do things like find the average from this data set. So that's where you'd have to approach this as finding the mean for grouped data. Next, in chapter 1, we're interested in measures of variation. So we want to know how spread out the data is. Okay, that's an extremely important parameter. One application of this is if we once again think about statistical quality control. Let's say you're producing an item, and from the engineers, you have certain specification limits. This might be a lower spec limit, and this an upper spec limit. You could see if you have a very wide variation in your output. Think of this as measurements you get from the output. If you have a wide variation, then you're producing defects. Anything to the left of this lower spec limit is a defect. Anything to the right of the upper spec limit is a defect. So wide variation is a very bad thing when you're looking at a production process. What we want is this narrow variation, right? So if this is now, some histogram of all your output, you could see it's completely contained within the spec limits. So now you're not producing any defects. And near the end of the chapter, you'll see there's a discussion about percentiles, quartiles, and box plots. Right? We could define a percentile as a value p such that p% of the data is below p and 1 minus p% of the data is above p. Then quartiles are defined in terms of percentiles. The first quartile is the 25th percentile. The second quartile is the same as the median, and the third quartile is the 75th percentile. And using these quartiles, we can put together a graph called a box plot. Now, a box plot would show 5 different numbers. It would show the median, the minimum down here. Okay. The left side of the box, or the lower end of the box, would be Q1. So that's the first quartile. Now, this here, you have to be careful. This is the median. That's sort of an X tilde here. It's not an X bar. This is the median, and this is X3, so that would be the third quartile. So this box represents the middle 50% of your data set, and then you would have a max up here. So these are also very useful graphs in a lot of scientific studies. And finally, I'll mention R. Throughout the course, we'll be talking about calculating statistics with R. I will not put R on any tests, but R will be on the homework. So it's important that you can do these calculations, and not just so you're successful on the homework, but just so you can take what we're learning in this class and transfer it to either other classes or other projects. So most of the time when you have to calculate statistics, you'll do it using some sort of technology. R is great to have. It's free. Sometimes it's a little cumbersome, but a lot of times it's very easy to use. So one of the first things you should be doing is downloading R to your computer. And you can see here are some basic commands. Now I put together another video just to get going using R. I call it Using R for Basic Data Analysis. This is available both on YouTube, and it should also be available on your Blackboard course page. So that's it for the overview. Again, my advice is to go through the chapter carefully, look at some of the class notes, and I will also have some examples from chapter 1 sort of solved in another video.